In this video, we're going to look at ways that we can write proofs. Now, this is the first time we've looked at proofs in OnLevel, and we're going to figure out the way to do that. On this first screen, I've included a couple of different important notes for you that we're going to include in proofs. If you look on the left side, I have my parallel line notes that are important. If you recall back to our lines that were parallel and cut by a transversal, let's say I have angle 1, 2, 3, 4, and 5 here. If the lines were parallel, so if lines parallel, then corresponding angles were congruent. So for example, angle 1 was congruent to angle 3 because those are corresponding angles. Also, we learned that if lines are parallel, then alternate interior angles were congruent. So angle 3 would have been congruent to angle 5 because those are alternate interior angles. And that's an abbreviation, both of these, for what we're going to use when we write our proofs. We've also learned about vertical angles, like angle 1 and angle 5 are congruent by vertical angles. Definition of angle bisector and segment bisector, we've learned about both of those. As is in the name, an angle bisector cuts an angle in half, whereas a segment bisector cuts a segment in half. So if I have, let's say, this angle here, oh, that's a really bad picture. Sorry, let's try that again. Let's say I have this angle that's being cut, and I say this angle is congruent to this angle, then this is a angle bisector because it's cutting an angle in half. Now let's say I have a segment with a line going through it there, then that would be a segment bisector because it's cutting the segment in half. You're also going to use definition of a midpoint. Let's say you have a segment, and on that segment you have a point that cuts it in half. Well, that would be a midpoint, so you know that this segment here would be congruent to this segment by the definition of a midpoint. Also, you have perpendicular lines, so if you have a right angle made by perpendicular lines, you know it's a right angle because that's the definition of perpendicular. Two lines that intersect to make a right angle. And finally, a very commonly used property is the reflexive property. The reflexive property occurs when we have the same shape, we have shapes that share a segment or an angle. So in this case, you have two triangles that share this side right here. So this side is congruent to itself by the reflexive property. We're going to use all of these in our proof writing, so make sure you have those in your notes and that you understand what they mean. So let's go dive into our first proof. In English class, whenever you write a paper, you always start by doing a pre-write or a rough draft. In math, when we do proofs, we do something similar, except for it's not going to be quite with words. We're going to mark up the picture as our rough draft. So in a proof, you always look at the given statement first, and you take the information from the given statement, and you mark it on your proof. So AB is congruent to CB, AD is congruent to CD. And then you can look at the picture, and you can determine if you know anything else to be true. In other words, if you're looking for items such as vertical angles or reflexive sides. In this case, I have no vertical angles, but I do know that BD is congruent to itself, so we're going to call that a reflexive side. And I can prove that these two triangles are congruent, and that's what it's asking me to do, by SSS. So let's actually write the proof now. And here's the method to do it. You draw a line across your page, and you start by putting boxes under that line, and you literally take exactly what's written in the given and you put it in the box. So the first given is AB is congruent to CB. So I put that in the first box and I write given below it. The other given is AD is congruent to CD. To D there. I'm just copying straight down and that's a given. Once you've copied all your givens down, you look at the picture and you decide, do I have any vertical angles or reflexive sides? If you do, then you need to put another box up top and write what that was. In this case, we had no vertical angles, but we did have a reflexive side, and that was BD is congruent to itself. So BD is congruent to BD, and we call that reflexive. Now, you look at your statements. You look at what you have, and you have one congruent statement. Congruent statement has a congruent sign in it, a second congruent statement, and a third congruent statement, and that is enough to show us the SSS that we're looking for. So in this box, put triangle ABD is congruent to triangle CBD by SSS, and you've proven those two triangles are congruent. So the last box should always be a straight copy from what it says prove, and you put your reason below it. All right, let's try this one. This one's going to be an extra step in it to get you familiar with it. So we start by doing our rough draft. HF is congruent to HJ, FG to JK. And you know that H is the midpoint of GK. Well, if H is in the middle of GK, that means it cuts GK in half. So GH is going to be congruent to KH right there. So once again, we're going to prove this one by side, side, side. So go ahead and draw your givens, your boxes for your givens after you draw your line across the page. HF is congruent to HJ, given. FG is congruent to JK, given. And finally, your last given is kind of a lengthy one. H is the midpoint of GK. And that's a given. And once again, I'm just copying straight from what's in the given into separate boxes. Now, you didn't have any vertical angles. You didn't have any reflexive sides, so I don't need anything else up top. I have one congruent statement, two congruent statement, but it looks like I need a third one. Well, if H is the midpoint, I can come down below it, and I can say GH is congruent to KH. That's what I marked on my picture, and that's by the definition of midpoint. And from that, I have my third congruent statement. So I can join those three together, and I can write the final box of the proof, which is triangle FGH is congruent to triangle JKH, and as we said, that's by side, side, side. So if you don't have three congruent statements, you got to get a third one. And a lot of times that's from the given where there's no congruent statement in it. All right, pause the video and try this problem on your own. All right, let's see how you did. AB congruent to AD. C is the midpoint of BD. So that means BC has to be congruent to CD there. And it looks like I have a common side, so it shares it, so that's got to be congruent. It's just another proof that looks like it's going to be by side, side, side. So let's go ahead and write in the givens. That always comes next. AB congruent to AD. Given, I'm just doing a straight copy once again. C is the midpoint of BD. Straight copy. And finally, I had a reflexive side, so I need to go ahead and put that on top. AC is congruent to AC. So I have one congruent statement, two, so I need a third. So I'm going to use the midpoint to get my third one here. BC is congruent to DC. And that's by definition of midpoint. And now I have my third congruent statement, so I can join the three together, and I can say that. Just copy the last box, triangle ABC is congruent to triangle ADC by side, side, side. All right, we're going to look at one more here. So pause the video once again, pay close attention to what it says in the given, and try it out. Okay, angle V is congruent to angle Y. WZ bisects angle VWY. So this is not a segment bisector, but an angle bisector because it's cutting an angle in half. That means this angle up here is congruent to this angle up here. And it looks like I have a common side, so it's reflexive on itself. So I'm going to have to prove these two triangles congruent by angle, angle, side. So now we come down, we draw a line, and we just write in our givens. Angle V is congruent to angle Y. WZ bisects angle VWY. And finally, if we have a reflexive or a vertical angle, we put it on top. So WZ is congruent to WZ, and that's reflexive. So I have one congruent statement, two, so I need a third. So below this, I can write, well, I saw that it's an angle bisector, so angle VWZ is congruent to angle YWZ. And that's, of course, by definition of bisector, one of those things we took notes on at the beginning. So that's my third congruent statement, so just join them together now and say triangle VWZ is congruent to triangle YWZ by AAS congruence. In the next video, we'll look at parallel lines inside these triangle proofs, but for now, that should hopefully get you started and get you busy with proof writing. Thank you for watching.